Alrighty, I'm going to get started here in a second. So this is a little bit different. This is actually the first time I've ever done a Warvox or audio talk that is more than 30 people in the room and actually gets recorded. So hopefully I've dotted all the T's and crossed the I's and so on to make sure I don't get arrested after this, but we'll see what happens. So this is a little bit different from your standard, /Metasploit talk that I tend to do a lot of. I've got one token Metasploit slide in this entire thing just because I have to, because otherwise it wouldn't be a talk I do. So, but for the most part, it's not related to Metasploit, which should be refreshing for some, and hopefully it seems like there's enough other folks doing Metasploit stuff that I don't really need to dive into it this much for this talk. Anywho. So the title of this talk is Acoustic Intrusions, and this really came about because I do a lot of stuff security related that doesn't really fit into your normal bucket of pen testing, social engineering, things like that. And whenever I find like a new data source, I get really excited and try to find ways to basically exploit it for all of its worth. So recent projects were a little NTP server thing where you find one way to leak data from a system, and you systematically exploit it for 2 years straight, gathering more and more data, so you've got this giant pile of stuff you can play with. So it's that kind of approach to I like finding data, find some way to leak data, and then mass abuse it so I can do something cool with it. And this kind of talks through some of the different ways that you can abuse data and things that are slightly outside of the typical pen test spectrum. So quick introduction, my name is H.D. Moore, CSO of Rapid7, founder of Metasploit, and still the chief architect. I work with James Lee, or Egypt as you know him, on the framework side and drive commercial product development as well. I've been doing this stuff for 8-something years and pen testing for about 14 now, so fun stuff. So any type of pen test, any type of security work, any type of security assessment, everything really revolves around actually having good data and having good things you can do with data. So we love data. Everyone loves data. Data is what drives this entire industry. Data is what the first step to actually making a decision about anything that's important. Whether you're someone doing the test, someone trying to prevent someone from getting in, or someone trying to build a better solution, you need more data to get there. Not this data. So we like Brent, but I don't really love him that much. So we like this kind of data, big shiny grass with stuff in it. But more actively, we like this kind of data that actually is stuff we can use. So having these giant visualizations of cool, funny security stats are great, but unless we can actually apply that to our work, what does it matter? So at the end of the day, we like data, but it has to be usable data. It has to be in a format we can consume. It has to be measurable. It has to be actionable. So I want to talk about information retrieval. This is really, every single task you do as part of a security assessment really comes down to gather some data, make a decision, and do something else. And that gathering the data piece is something we've been getting much better at for the last 10, 15 years. We've got great tools now for just about every type of data collection that we do in a typical environment. Lots of open source tools, which is awesome. But it really all comes down to having good data to start with. And there's really 3 different approaches to gathering data. You can start off by saying, let's figure out what's already out there that we can basically gather from some place that someone may not realize it's there. Things like dragging it out of a Google cache, searching for it in other people's web logs, basically digging data out of any third-party resource you can without really going after the target. Sometimes it stinks. Sometimes you have to actually get close to the target and start monitoring for it, whether that's Wi-Fi, whether that's audio, whether that's following them around in your car to figure out what they're doing. Those are all things you need to do. You actually have to be near the person to do it to monitor them, or have an awesome headset like this. So, or you can actively extract it from your targets. If anyone's seen the movie Brazil, you'll know what this is, but everyone else, it's not just a crazy baby. This is an interrogation room where they retrieve information. So sometimes you have to get medieval on them. So computer data is really easy to collect. You talk about things like IP addresses, DNS, all the various stuff we use for fingerprinting, for footprinting, reconnaissance. This is all generally easy to collect. We've got tools for it already. We've got processes for it. We've got really good scanning tools. We've got really good frameworks. We've got the p-test stuff, which is doing a good job of actually describing how to go about collecting that data and what data to collect in the first place. So for the most part, we've got computers figured out from how do we get bits and bytes about IP addresses and domain names. We've basically been beating that horse for a long time. We've actually got some good progress. What we haven't really done a good job of is getting data in a manageable format from every other system out there. The computer is only just a storage device at the end of the day, or in the best case, a pivot, a proxy, an agent, something you can abuse and reuse. But there's so many other ways to go about getting into an organization, compromising security, getting access to the data you want. And most of the things you're doing as part of a security assessment are protecting the data. So if you can find other ways to get to the same data that don't involve the computers, great. I know there's some folks here who will be talking about things like that, both around social engineering and other ways to get access to data. And And I won't go into it too deep, but in general, data is freaking everywhere. Get a pencil, go to your hotel room, find that little message pad inside your drawer, and do a little scribble across the top, and you'll find the last phone number the person dialed. Just hang out in a lobby for a while and start listening to what people are chatting about. Everyone who was stuck at an airport for in the last day or two probably had an overwhelming amount of other people's information shoved in their ears as they walked around. So there's lots of great things out there. I mean, I love those trash cans near the ATMs. It's so convenient. Like, I always happen to drop something and have to pick it up when I'm near them. I don't know why, but it's one of those things like, let's take the most sensitive data we can, tell people to put it into this bucket, and then leave the bucket next to the device where you can easily get to it in a secluded location. So, anyways, someday I'm just going to walk around just picking up all those trash cans, taking all the trash out for those, because it's too easy. And we're constantly being hammered by random background noise that gives away cool data. Anytime someone's cell phone rings, you know what vendor it is, generally by the ringtone. Anytime someone picks up the phone and says their name, you know their name now. So we're constantly getting lots of really good data, and we're not really good at exploiting that data for our security assessments. So capturing data really isn't the challenge. We can run around with voice recorders, we can have the big crazy headsets on our ears, we can do all this stuff if we need to, but you can have your Pony Express running around capturing Wi-Fi, whatever you need to do, but at the end of the day, you can't really, unless you can do something with the data, it doesn't really matter. And it comes down to cataloging it, sorting it, indexing it, being able to actually decode it. For a lot of video-based stuff, you can use OCR for pulling images down. There's a great talk a while back about a particular vendor that was exposing user screenshots online, and those screenshots could be OCR to grab all kinds of great automated data back out. So just a case where just some little leak of data and large amounts of it could be massively abused using OCR. Voice recognition right now is just awful though. So for audio stuff, you don't really get good transcription services without basically handing it off to a call center someplace or a low-paid employee someplace to do it. And by low pay, they still get really expensive if you're giving them 10,000 calls, as they found out. Even like Google Voice doesn't really cut it there. So in general, there's lots of great data out there, but it's really hard to index and catalog some of it because it's in a media that isn't easy to extract. If we go to audio data leakage, which is my fun way of describing what happens when someone tells you something they don't want you to know, if you go beyond just plain eavesdropping, there's lots of really neat things you can do just with basic background noise. Like anytime you hear the ding message, the error message in Windows, you can easily tell what it is. Anytime you hear, my favorite one is the UAC pop-up. So it has a distinctive noise in Windows 7. So if you're sitting in front of a receptionist desk, you hear the UAC ding going up. Like, hey, look, they're using Windows 7. They're actually have UAC enabled. Soon you come back and send that same nice receptionist a Trojan PDF later on, and you know what to do with it. Anytime you've got a room full of folks with a bunch of cell phones, I'm actually hoping we'll get an example here. Of someone's cell phone ringing, we can basically call out what vendor it is, and based on that, start tailing your attacks to that company. So if you go to an organization, all you hear are the BlackBerry ringtones, and hey, it's BlackBerry. Let's focus on BlackBerry server exploits. Let's focus on BlackBerry client-side issues. So it's also fun to just go into the lobby of the building, start recording, and just start making a list of everything you find by going through the recording. And these devices are super cheap. I mean, my freaking iPhone can record audio better than most devices 10 years ago. You may need an external 2.5-inch jack and a microphone, but those are really cheap, and you can do a lot of great things with a cheap mic these days. So an example of this is in my hotel safe this year at Black Hat. It was just like every other horrible hotel safe out there. They're insecure as hell. You can usually just pull them out the wall, break the little bolt off, and be done and walk away with it. Or they have vendor backdoors like hard-coded PIN numbers or default PIN numbers, or the little swipe card dealy whoppers where you basically take a mag stripe card with a certain number on it, use that as the key. There's lots of different ways. These things are just terrible devices. But I found a new way that these are terrible, in that the particular safe that I had in my room had a different touch tone for every key on the thing. And the way the closet was set up with the safe is right up against the wall of the outside hallway. And it was that way for all the suites of the Aria. Oh, did I say Aria? I mean, the hotel I happen to be staying at. So what you'll notice is that as you start going through these audio samples, every tone's a separate frequency. And this is actually recorded from through the wall outside while my friend was pushing the safe buttons. So I was able to basically decode the frequency of every button. And then when you decode it, you can then figure out what the numbers of the safe are. So little things like that. I mean, this isn't mind-blowing or anything like that, but there's so much data flying around, all you need is really a good tape recorder to get it. What's interesting about this particular sample is for folks who aren't heavily done a lot of work with like audio processing or DSPs or things like that, most telephone audio is basically 8K audio, which means it's Nyquist frequencies around 4,000 hertz. So anything above 4,000 hertz you'll never be able to get through a standard analog telephone. And to make things worse, the POTS lines actually have a cutoff around 3,500. So if you're on a landline only, you're never really going to get over 3,500 hertz on a call. So one of the neat things you can do is if you ever detect a signal over 3,500 hertz on a telephone call, you know it's actually being sent and received digitally without ever getting truncated on POTS or terminated on POTS. So it's a neat way to figure out whether someone's digital only or not based on that. The interesting thing about this is all these safe tones, with one or two exceptions here, are actually above 3,500 hertz cutoff, which I just thought was strange. Like, it seems strange that you would keep them right around that, just above that level. So anyways, I was wondering if my conspiracy theory at this point is that they're all above 3,500 hertz, so you can't tap them through a cell phone, or you can't tap them through an analog line because they'll all be basically above the frequency in which they cut off. Anyways, so random stuff. So if you ever see something above 4,000 hertz, you're never going to hear it through a telephone, and that may have qualities you can exploit later. So telephones are awesome, awesome systems. No one cares about it anymore because they're old and busted and boring, and you leave it up to a few people to really just wreak havoc with these things still. Can I get a show of hands? Who actually does telephone-based security assessments as part of their work or job or consulting? Okay, we got maybe 3 of about 1,000. So give you an idea, it's definitely an underused skill. There's some folks in this room who are just gods at telephones. They can whistle and launch nukes. I'm kidding. I don't see Kevin quite yet, but anyways, I'm sure he's around here. But telephones are great systems. We still rely on them for all kinds of things today. I mean, anytime you want to reset your password at IT, they generally do a callback. Anytime you call some organization and you want to sound official, you can give them your voicemail number, and it's within the range of your company. You can then basically spoof that number. And taking over voicemail boxes is so easy that this is still a very effective way to bypass security in ways you otherwise wouldn't get access to. There's all kinds of crazy stuff out there. I mean, you'll find things like modems and faxes, of course. Modems are still a very small part of the overall telephone pool these days. It's basically, if you're trying to word dial using standard dialing tools, like basically a bank of modems, word dialing is absolutely worthless. You can't find modems these days fast enough to make it worth your while. It's just so slow, and there's so few modems out there that it's not worth doing. If you're trying to use, that's kind of leads to the Warbox talk. It's kind of ways to get around that, things you can do to improve the situation. But modems are basically old and busted, not really that useful today. You still find, nice Nortel PBXs out there, default passwords and things like that, but for the most part, you're not going to get very far with them, unless you want to turn off the radio tower. So there's lots of other interesting gear out there. There's HVAC systems, there's radio tower transmission systems, there's all kinds of cool SCADA gear out there that's still on these things. Some are actually voice activated and touch tone managed, some of them are actually database, some of them are really weird protocols over analog tones. So all kinds of cool stuff still. Interactive voice response systems are fun to play with. A guy named Metal Storm in New Zealand did a great job of doing a talk on IVR brute forcing. He's got some tools for it, but it wasn't widely known why they published. We're trying to actually get that more out there. Anytime you call a company and hit 0 and you go through the employee directory, you can basically enumerate all the internal users. So if you're running against a company that's not listing all their email addresses on websites and all your standard tools like Maltego and so on have failed to identify users there, you can all just pick up the phone, dial 0, and go through the employee directory to figure out who's where and start basically writing down a list of users that way. And it's a great source of information for doing phishing attacks, for figuring out email addresses, for figuring out titles. We'll get more into that later. If you ever dialed a phone number or gotten transferred, or as soon as you dial, you hear like doot, 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 doot in the background, well, that's a DTMF tone actually forwarding you someplace else. All you need to do is basically take that recorded audio, run that through a DTMF decoder, and you can basically get the list of whatever that is. Oftentimes you figure out that's actually the internal extension code. So it'll be X for transfer and then the extension code to transfer to. So by having those numbers, by decoding it from the call, you can then basically dial straight into the operator, transfer the extension directly, and bypass the forwarding, or figure out what other extensions in that range you can play with and what else is out there. So there's all kinds of cool stuff you can do, and just basically decoding DTMF from calls you already make. Lots of PBXs, lots of voicemail boxes, and you can actually still find dial tones. Like, just you dial a number, and you get a dial tone, and you can make more calls. You can still find them today. I found one this morning in Kentucky, so we'll get a demo of that later. I have no idea whose it is, but be nice to it. So for voicemail boxes, these things expose huge amounts of really cool data. You get the name of the person, you often get their title, you get their cell phone number if they're out of town, or if they say, if it's emergency, please call my cell, blah, 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 blah. That's great stuff, because you can't really find people's cell phone numbers easily, unambiguously otherwise. Figuring out that they're out of the office is great. This is so you call IT and be, hey, I'm out of the office, I can't get to my account, can you reset my password, just leave me a voicemail with the password, thanks. Then dial into your voicemail box, take the password, log in as them, and you're done. So super easy pen test. All it takes is like 2 phone calls. One to log in the voicemail box default password, and one to call IT and beg for it. Getting the cell phone numbers lets you target their cell phone voicemails as well, so all kinds of cool things you can do there as well. But this is great for figuring out organization relationships as well. I did a pen test last week where half the numbers were out of the office because it was apparently when the stocks are down, all the traders go away. this particular organization. Like, screw you guys, we're done. We already lost money. We're going on vacation. So I called, and every one of these traders basically sent me to their assistants and their out-of-office voicemail greetings. So I had all the assistant numbers, and the assistants had no idea how to set up a password on a phone. So I basically got all the voicemails from the assistants' voicemail boxes as opposed to their voicemail boxes because of the way they set it up. Anyways, lots of fun stuff. So if you ever find an unused voicemail box, that's a gold mine too. Because then you can basically register your own greeting message saying, hi, I'm Bob, new IT employee, and then start calling people after dialing into the line and saying, oh yeah, this is Bob, spoof the number if you need to. We need to reset your password. Please call me back and tell me what password you want your account set to. And it's like, oh, really, it's not working. What password do you currently have set? So you can work your way there, but you need to establish that first level of trust before you can really get them to give you the next piece. And by having basically a voicemail box within the organization, it's very hard for them to disbelieve you if you say you're an internal employee if you already have a voicemail box. Because everyone assumes that phones are secure and no one's ever going to screw with them. So going to that point, everyone basically ignores telephone systems. There's all kinds of crazy stuff out there, but they're not really covered by any regulation. They're not really mandatory for tested by any kind of compliance regulation. I think there's actually some war dialing and some compliance regs someplace, but that's only for modems. It doesn't actually involve testing PBXs or any other type of voice system out there. It's not something that most auditors even know how to test, let alone care about testing. And there's really no commercial driver for it. Probably in the history of doing pen testing, I've probably had maybe 15 customers out of probably 1,000 plus ever ask about war dialing, let alone actually want to engage it. And when they hear early days how long it took and what the results would actually be, it's like, well, it's probably not worth their time to do it. So it's a case where you just don't see any commercial drivers for it. There's no regulatory drivers for it. The tool set's pretty minimal these days. You've got basically iWar for Unix war dialing, ToneLoc, of course. I think SandSweeper is actually offline now, or I forgot the status of it, but there's a couple commercial tools out there that have now basically disappeared. But overall, it's a sad state. So let's fix it. So Warbox 2, which is what the real meat of this presentation is about, is not just about, I realize that I've never actually given a Warbox talk to a big audience before. To anybody, there's been so few information out there about this thing to start with that no one really knows how to use it. I still get probably 10 emails a week from people saying, how the hell do I install this thing? How do I set it up? How do I use it? So people have an idea that it's out there, but no idea really what it's useful for and what you can do with it. So I've been working on it in the background for a long time as kind of a pet project. Of course, I work on Metasploit full time. This is just kind of my extra project, if you will. And just kind of a quick introduction to it. Warbox is a Ruby on Rails web application. So a little web interface you log into. And it can make lots of phone calls. It's got a built-in VoIP stack. It can make phone calls, and it can record the audio. Unlike a traditional war dialer, where it's calling a modem and then trying to negotiate and waiting for the connect and then looking at the banner and so on, it's actually just making a phone call and basically just doing a dead dial. You'll get a phone call from it, you'll pick it up, there'll be nobody there. You'll go, hello, 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 stop calling me, you weirdo, blah, 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 click. But it does that to lots and lots of numbers at a time. So you can do hundreds of concurrent calls, you can do 10,000 plus calls an hour. It's crazy, crazy fast for mass dialing systems. And it does that by using multiple voice providers and basically load balancing across all of them as it makes calls. So you can mass annoy entire cities. So Jerk City, 2011, if you will. So lots of cool things to do with it, and it's great for just gathering all the initial data. The tough part's now that you actually have all this audio data, how do you actually extract stuff back out of it that's useful? For me, just having tons of audio data was great because I just picked up, had a little headset on for 3 months going through all the calls, figuring out what the hell I found because it's been 20 years since I was really doing war dialing, I guess, or 18. And it's all BSD licensed. So basically, it's a giant phone call app that records whatever it picks up and then lets you mangle the audio data. So here's kind of what it looks like from a signal perspective. You get lots of little graphs of basically the amplitude and the frequency. On the right, you'll see of each of those columns the frequency graph. Whatever the highest little blip is on it is the most present frequency within basically the strongest frequency within that signal. And on the left side, you can kind of see the standard waveform. So you'll see things that jump out right away, like the second line down here from the top. You can tell that those are fax machines. They look like fax machines. They've got big fat bars going across. Unless someone really knows how to whistle, that's definitely a fax machine. You'll notice things correlate, like the frequencies correlate with the signal graphs. You'll see that for the fax machines, you've got one big spike right in the middle. For things like voice, you basically see kind of a flatter tone all the way across. And one thing I've noticed is that even if someone's speaking different words, most people have the same tone of voice and have the same frequency response range within their voice. So if you find someone's basically cell phone message and you take that and then you dial every home number in the city, you can then cross-reference that with their voicemail message pretty easily and actually have a pretty good idea of what matched what. So you can find people pretty easy. It's like the Uber stalking tool for audio matching in that sense. I'm sure the NSA is better stuff, but mine, is free and it's BSD licensed, and you can make it better if you want to. So if you're trying to word dial for modems today, it's pretty slow. WordVox can do 10,000 plus numbers an hour, and then you basically crunch the audio to figure out which ones are modems based on frequencies. But only about 4% of all the actual connected pickup lines out there are actually modems. I dialed a couple ranges in Louisville, and what you'll notice is that I dialed about 2,000 numbers downtown area, only about 400 picked up, and of those, I think only like 16 were modems or something like that. So it was a pretty small subset. And one thing you'll notice, a lot of those modems are actually telephone equipment, so you don't want to screw with those, or the Fed show up at your door, and it's not fun. There's actually one of them I want to play later, which is crazy. Actually, you know what? Let's do a quick break, because this was too funny. Sorry. You can tell I like playing this stuff a little bit much. But there's some really crazy crap out there as far as telephone systems go. And this is one that I found, and I was like, well, that's interesting. And I was like, wait, what's that next message? Wait, what's the next message? Anyway, let's see if we can pull it up real quick. So just give you an idea of some of the wacky stuff that's out there.
Have reached a non-working number at McKinsey & Company.
Yeah, so
Have reached a non-working number at McKinsey & Company.
that's not very exciting. Let's find the next one. Let's see. Dun, 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 dun.
Have reached a non-
Sorry, I think it's the next page. Here we go. So this is the telephone switch that is owned by the telephone company that I thought was a little bit interesting in how it worked.
Enter your authorization code now.
聆听中文录音，请按星号2。如果需要廣東話，請撳星符號3。
So that's a Boston telephone switch. I don't know why it's in Chinese, but it's awesome.
Enter your authorization code now.
聆听中文录音，请按。
So this is disconcerting to find one of our like switches in the oldest part of town, one of the oldest buildings with a Chinese greeting for entering your authorization code. So I'm sure it's harmless, but it was still funny to run into. So you run into some really bizarre stuff out there. So basically, the way you identify a modem versus the fax versus the voice versus a human is all based on frequency analysis. So if you see something around 2250 hertz, for example, you know it's a modem. If it's between 1800 hertz and 2200 hertz is the strongest frequency, it's generally a fax machine, but not a modem. So figuring out fax versus modem took me a long time. I've been going through way too many ear-splitting calls to figure out which one was what. But that ended up being a pretty accurate descriptor, and I've actually been verifying that by dialing all of the fax machines with a modem and then dialing all the modems with a modem, and basically verifying that the results are actually right. So it's pretty solid. So here's an example of what a modem looks like versus the fax from a signal graph. So you can easily see, well, hopefully you can see that. It might be a little bright. One of them is a big, fat, very kind of straight, long, pipe of a signal, and the next one's kind of bursty. We've got these big bars. So this is basically the difference between a modem and a fax as far as the waveforms go. This is in the frequency graph. Frequency graph's a little bit different, but the frequency graphs are actually much more similar than the signal graph. So it's actually a case where doing like graphic visual form analysis is actually probably a better way to do audio fingerprinting than a lot of the frequency analysis stuff, just based on actually matching forms and matching shapes. But I'm not quite there yet. So one thing that's neat about modems is you can actually fingerprint individual hardware systems based on how the modem negotiates. So keep in mind, all we're doing is waiting for the modem to pick up and then recording whatever it tells us on the phone and then saving it off and analyzing it. So you can find a lot of neat things just by figuring out what a particular piece of hardware sounds like when it picks up the phone and then scanning for that particular hardware. So one thing you'll notice is, in this case, I dialed 400 different dial-up lines in the US and basically recorded all of them and then graphed them and then basically grouped them by matching waveforms. So what you'll see here is there's only 3 types of modems being used for all US dial-ups for internet access, like Juno, AOL, Earthlink, all those failed dial-up companies. They're actually all now using the same modem banks across 3 different hardware vendors. So you'll see that I've kind of highlighted some of these things in little purple boxes, but you'll see big listings of very similar graphs, and you'll see that there's 2 or 3 different kinds here. I think all 3 are represented here. But if you dial these up with the modems instead of actually just through the audio side, you notice they all have different login prompts too. So they're all very distinct login prompts for particular hardware. So you can very easily fingerprint the hardware. I was working with a friend of mine at a industrial automation company, and he basically gave me the audio recording of the pickup line for one of the modems used in the SCADA industry for some kind of control system around pumps. That thing was very easy to fingerprint as well because it was an older model, it had a different firmware, it had a different speed of negotiation, it had very distinct settings. Because of that, the waveform was very distinct. So he could then dial all of basically his plants and figure out which one still had that device present based on just the waveform of the audio. So even though it's a modem and even though it's just something screaming in your ear, you can actually extract useful data out of it just by looking at the picture. So modems really aren't that interesting. Voice numbers are where all the really cool data is today. This is where all the fun hacks are. This is where all the fun abuses are these days. But processing voice is a pretty big challenge still. No one really does it well. Even like Google Voice auto translations are mostly there just to laugh at. They kind of give you they're like, oh my God, my aunt's dead. Oh wait, she just said that her favorite color is red. I mean, it's a case where if you believe what it says at face value, you're running the hospital way too often, just because the way it translates things. So even that type of voice translation is not that great these days. The rumor was that when Google Voice, actually Grand Central Station first opened up, instead of that, they had this automated translation feature, but it was actually being done by low-paid workers overseas to translate the numbers by hand as opposed to doing it internally. And eventually they got the software better, but there was actually a gap. If you look at some of the old Grand Central Station transcriptions, they're actually much better before Google bought them. Because when Google bought them, they switched over to a software stack, and they realized, hey, this thing's entirely broken, I had to go fix it. But they never really got there. Basically, you're still not there as far as voice detection. I've got a car that has a GPS system that you can basically tell it to find things, like Chinese restaurant. And like yelling obscenities at it and seeing where it takes me. So far, if you yell hookers and blow, it takes you to Thai restaurants. I don't know if there's correlation, but it seems to know something I don't. It was just surprising. It's always fun to see how these things misinterpret data. So right now, none of the voice systems out there really are that good at detecting real words. I built one myself. I used like all the, what do you call it? I forgot the name of the software stack. Basically, there's a university-developed software stack doing software analysis. They've been 2 or 3 revisions of it, a couple of commercial derivatives. Even bought the commercial license for this thing, and it was still terrible. Still couldn't really pick out more than a small dictionary. So basically, if you're doing voice analysis, if you're looking at detecting more than 15 or 20 words in a particular set of sample, you're hopeless. Like it is, even if none of those 20 words are present, it'll weigh high on one of those words enough that you basically choose something that's not there. So you have to give it a very limited dictionary to choose from for that to be reliable. So it's okay for text for menu systems and IVRs, and absolutely terrible for actually doing transcription, which is what I was trying to do. So one thing that is really useful when you're doing large blocks of numbers, like dialing 20, 30,000 numbers at a time, or all of Moscow or something like that, especially if you don't speak the native language, is you want to be able to automatically group things that sound alike and then be able to pick out things that don't sound alike. So on that big screen we saw earlier, you could see that there was some pretty obvious waveform differences. You can basically look at the screen and say, okay, these ones look different from the other ones, therefore let's go look at them because they look different. But it'd be nice if it automatically grouped things based on what sounded similar. And when you look at automated voicemail messages, they all look exactly the same. It's all like blah, 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 blah. They even mentioned beep. So for those ones, you want to be able to pick out similarities, but you can't do that just by looking at the waveform because they're almost identical looking as far as that's concerned. So you have to do things, you have to basically go deeper and do a little bit more frequency analysis. With Warfox 1, I used 2 methods of doing it. One was basically silence versus noise. So basically the patina of silence on the call versus noise. So, quiet for a quarter second, then a little burst and quiet, So for folks who had a very distinctive speaking pattern or, recorded messages that were exactly the same, it was actually pretty good. So here's a graph of 10,000 numbers that are colored based on automatic group names that are basically pulled out of a hat at random. So it's an entire 10,000 number block. I think this is like 512, 454, XXXX in Austin. So you'll see that the very top left corner here is basically 0000. The very bottom right here is 9999, or basically not, yeah. And you'll see these big stripes of things that look the same. So anything that looks the same here had the same silence versus noise pattern across the entire base of the phone call. You'll see that there's big blocks of empty numbers, big blocks of numbers that sound pretty similar because they're error messages from the telephone company, or they're the same greeting at a company where every incoming call goes to the same voicemail system, things like that. But if you do the exact same comparison, but now instead of using silence versus noise for it, you use frequency analysis to figure out what was the top frequency of this call. Just look at the top frequency, just single top frequency using a DFT. You get a different view. So as you notice, you kind of bounce between these 2 views here. You'll see that even though silence versus noise is pretty good at picking out how things were structured, the peak frequency actually did a better job of finding things that are similar. So stuff that didn't show up as being part of a particular group and the silence versus noise stands out very clearly in peak frequencies. Unfortunately, peak frequencies aren't enough either because there's many peak frequencies and they overlap, and it's not a really good metric. And time shifting and things like that cause all kinds of problems. So peak frequency ended up being probably the best way forward to identify similar calls, but just doing a single peak frequency was really tough. So there's a bunch of problems with Warbox 1. It had a buggy IAX2 library. IAX2 is the VoIP protocol it's using to make phone calls. It's way more sane than SIP in that it only has a single control channel and data channel altogether. It's basically one UDP stream. You can do it from behind NAT, and it's super easy and super small and easy to process. The reason why VoIP carriers don't like it is it's really heavy for them to process on their side. It has a lot of work for you, like DTMF decoding on the server side, and passing DTMF down as decoded extra data in the stream back. So it's a little bit heavier for the VoIP ISP to support, and therefore most VoIP ISPs only support SIP. The good news is you can use something like Asterisk or FreeSwitch or Trixbox to basically route IAX incoming to SIP out, and basically run your own little mini Asterisk server to route the call. So if you have an ISP that only supports SIP, you can still use it just fine. So Warfox had a bunch of problems with IX2 because it used libIX client, which is broken and buggy and unmaintained, and it would hang randomly, and you couldn't tell it to not use the hardware in the system. So if you didn't have a sound card, it wouldn't work, and if you had a sound card, it wouldn't work randomly, and it just drove me crazy. It scaled really poorly because it used SQLite in the back end, which is just terrible, and it had the hard-coded path to all the files in the actual database, which meant whenever you moved the database around, the whole thing went to hell, and you lost your data. At least, it was pain. The biggest problem, though, is anytime that audio was time shifted, like you basically started off half a second into the call versus the second of the call versus the beginning of the call, the first frequencies all got mangled pretty well. Just keep in mind, we're only looking at 8 kilohertz audio. So 8 kilohertz audio is basically 8,000 samples per second, and those samples are only 16 bits wide each. So 2 bytes per 8,000 samples each, and your peak frequency there is 3,500. So if you start halfway into that, and your peak frequency that you can detect halfway into that sample now drops down to only 1,200 hertz, things like that. So for voice, it was okay, but for a lot of voicemail systems, things like that, basically the time shifting broke all the signatures I used to have, so I had to throw them all out. They're spending way too much time writing them all. It was hard to find audio that really sounded the same efficiently. You would basically look for it. You could basically cross-reference everything once. But it was really, really slow to cross-reference. It'd take probably 24 hours to cross-reference 15,000 samples. It was just crazy. And that's with 24 cores and a giant server and everything else around it. It was a huge pain. So I started rewriting all of Warbox, and I'll basically be able to jump to some demos here in a second. The first major change was migrating to Postgres. So everything's in Postgres. The data, the MP3s, the graphics, every piece of the call is basically in the Postgres data now. And we're leveraging a lot of Postgres-specific features for doing the matching process, which we'll talk about more in a second as well. I got so sick of libIX2 that basically the morning of Black Hat starting, I wrote my own IX2 library in time for the B-Sides talk, which has a little bit of overlapping content with this, but not too much. LibIX, basically the IX2 client, is actually implemented in the Metasploit side. So instead of writing it for Warvox, I actually wrote it for Metasploit, so Metasploit can make phone calls all by itself now, which is nice. So you can do cool things with Metasploit on voice just by making phone calls with the IX, and we'll talk about that near the end. So now that this client's in there, I basically imported the librex code back into Warvox. Now Warvox uses librex and IXC library to do it. So IX is just the transport. You still have to write the decoders. So I had to write G711 decoders for ALAW and ULAW, which are actually not that hard. Just one big lookup table, basically, for each stream. So super easy. And because it's using IX2, you can basically route that through Asterisk, FreeSwitch. You can also use an analog card, an actual phone company line coming in if you need a permanent setup. So you have lots of ways to basically make phone calls out through IX2. So the frequency system had to get basically thrown out. I literally spent 3 months writing signatures for huge array of systems that was eventually going to get released before I got pulled into RAP 7 and working on the whole Metasploit side since. Those signatures became worthless because I couldn't reverse back out where I started from. I couldn't adjust them. I couldn't use them. They were basically signal versus noise and peak frequency based, and it wasn't good. So we rewrote the whole thing from scratch. Now it takes the top 5 frequencies for every 1 second of audio. It combines every 4 seconds of audio's top 5 frequencies, and then basically multiplexes all of those. You get a large number of top frequencies within a particular sample. It rounds them to the nearest 100 hertz, and then it samples the same audio 20 different times at what 20th of a second intervals through the entire sample set. So you can account for time shifting up to the full second across the entire sample, and it basically weighs it properly and everything else. So you end up multiplying the size of your sample by 20 and doing tons and tons and tons of FFTs across the entire thing to get your data. So it's crazy slow to generate each individual sample, but once you have the sample data, it's much faster to match against. So you drop in that's a low power signal over 100 dB, and basically this ends up becoming 30 seconds of audio will turn into about 500 4-second fingerprints. They're quads of top frequencies per every 4 seconds of audio. So we'll actually look at some examples here in a second. So 100, 200, 300, 400 would basically mean that the top frequency of the first second was 100 hertz, then 200 hertz, 300 hertz, 400 hertz. Because these are all being rounded to 100 hertz, you can basically divide them by 100 afterwards and get much smaller numbers, so 1, 2, 3, 4. And because the maximum frequency is 4,000 hertz, because of the Nyquist limit of 8,000 hertz audio, you're basically never going to get a number higher than basically 40 for these. So if you take these four numbers together and you pack them as in bytes, and you put all the bytes together and unpack to get it into a 32-bit integer, you end up coming out with a single 32-bit integer representing a 4-second bit. Anyways, all this really means is that for a 30-second audio sample, you get 500 32-bit integers back out as your signature data. And that becomes really useful later on when we start doing matching. So we actually store these in the integer array type in Postgres. So it's a column type that actually has an array built into it with native operators built into Postgres doing array intersections and array cross-referencing. So the reason for all this crazy signature stuff is it's really painful to do up front, but once you have it, you can match using a single SQL query. So every audio sample is an array of integers. You create the fingerprint from the source audio, and you can basically take that fingerprint and match against all your destination audio and easily tell what overlapping numbers are in source A and source B, and that basically tells you what the match percentage of that audio is. So it'll tell you how much of A is in B, and you can actually do a reverse match of how much of B is in A and so on. And that gives you an idea of how similar two particular samples are. It requires the contrib libraries in Postgres, and this is a little bit boring, so we'll do more demos here in a second and skip through this. The idea here is that the SQL query actually looks like this. It's a giant, basically blob of your sample that's an AND, which is your array intersection across your fingerprint, and then you divide it by the number of samples, multiply times 100, and this gives you the percent of A that's in B all the way down in a single SQL query. So you turn all of your auto database into a single SQL query to cross-reference any sample against any database of samples in one shot. So you just tell, hey, SQL this, blah. So you can basically do audio matching directly through SQL now and not have to worry about doing anything once it's in the database. So all your CPUs up front to crunch the audio. Once it's in the database, you can easily match against everything else that's there. The reason why this doesn't use like Music Brains or one of those other existing libraries is they're all optimized for sample lengths greater than 20 seconds, and they can't do anything less than that. Whereas mine's really optimized for sample lengths less than 1 minute, and can actually do a good job at 2 or 3 seconds. So that's the reason for it. It's really focused on short audio samples based on peak frequencies versus on musical attributes. So that's why you've got this format and the structure for it. So in this particular example, you can see the top one was 100% match because it matched it against itself. The second one is a 76.9% match and all the way down. So this is actually what it looks like inside the Warvox UI now. When you go to a particular sample inside the system, you can click on View Matches. That does a live cross-reference against the backend database of that sample against every other sample and shows you any match greater than 50% on the backend. So you can see that this particular system, and we'll actually look at this. This is from yesterday's dial job. We found one audio, and then we found one that was 82.9% match, then another one that was 79.1% match, and they both show up here as green because we know they're pretty similar. And if you look at the waveforms, you can see they're pretty similar as well. So it's a very straightforward match on it. And we'll play the audio, and you can hear that they're the exact same greeting for the same law form, just slightly offset time-wise. So part of this was creating all these signature tools. So one of the big changes in Warvox 2 is there's a whole set of command line utilities for not just exporting out raw audio data and exporting lists out, but actually be able to match them in real time against the backend database. So you can export all the data from a particular dial job out to a directory, and that creates a directory with a bunch of raw data files in it. You can then use audio trim on the data files to cut various seconds and take windows of that audio sample out. And you can actually pipe that to SOCKS to play the raw audio. So if you want to hear the audio, you can basically just do audio trim, pipe to SOCKS on the command line. That'll play the audio, and you can see what sample you're listening to. Once you're happy with that being your source sample, you can then pipe that into audio raw to fingerprint, and that'll actually generate the raw fingerprint array for you right there on the command line. And if you want to then match that query against the entire backend database in one shot, you just pipe that to identify matches and the maximum number of matches you want. So all from the command line now, you can take an audio sample, extract a signature from that, cross-reference the entire backend database, and then show you all the matches based on match percentages, all in one shot. So it makes it really easy to basically match stuff in the backend. Some of the use cases of this stuff is the whole news of the world style hacks where you break into everyone's voicemail. You can mass audit an entire company's voicemail system in one shot if they do caller ID-based authentication and don't have PIN set. So you basically take your list of executives' voicemail, you dial them all with the caller ID set to self, which in Warvox tells it to spoof everybody from themselves. So most times the phones don't even ring, they go straight to voicemail, and you can fingerprint the AT&T, you've got 5 new messages, or please enter your password, or whatever the string is. You can actually create signatures based on those text blobs, or those speech blobs, And anytime you find you've got X new messages, you know that you actually busted their voicemail, and you can tell them to go put a pin in their voicemail box. So if you're worried about things like people breaking into your voicemail and listening to your executives' phone calls, things like that, you can use this type of technology to easily build out fingerprints for AT&T, Verizon, et cetera, then mask out all your own employees and make sure they're actually setting pins properly. Again, this depends on what your policies are for your company and how you do things. But I found it really useful for that. You can fingerprint PBX systems just based on the greeting. So if you take the greeting of "Welcome to Cisco Unity Call Center," or "You've reached Meridian PBX, your user's not here," whatever the audio sample is, you take any audio you find in the wild and basically search that across your existing database. And the great thing about this is once the signatures are in the database, you can always search for them later on. So you can basically keep dialing tons and tons and tons of systems, and eventually you find something new and shiny, like, hey, look, a satellite receiver, or hey, look, a radio tower. You can then basically cross-reference that source audio sample across all your existing database and find any other instances of that data that you found previously. So it's basically a data set you can keep mining as you find more things and find new signatures. You can find landlines porting to mobiles very easy. You can do lots of voice matching across large samples. The demo I did at B-Sides this year was dialing all of the Rio Hotel, finding the guy who managed HR, and finding his home number, basically by matching his voice against the entire list of residences within the Rio. And we found him pretty easily. He was in the top 3 matches. So it's just like, hey, look, we found Bob. So pretty straightforward. And it works pretty well for it. I mean, the spooks I was talking to about it, like, you suck. I'm like, okay, well, share your stuff. No, okay, well, use this. And it's actually totally a tangent, but if, let's say, you happen to develop something on your own that happens to fall under something that people do in the national security level, you may think they may be upset about it, but a lot of times they're waiting for someone to do it publicly so they can talk about what they're doing more internally and get more funding and say, hey, this is actually something people know how to do. So I was actually surprised that there's actually some good backlash for dropping some things from the spooks, at least, because they say, like, hey, great, we can now talk about this stuff. It's now no longer classified because someone else did it outside of our realm. So anyways, useful stuff. So you can now do VoIP calls directly from Metasploit. So it's got it'll actually decode DTMF in real time too, so you can control exploits directly from your phone now if you want to. Just write an aux module that dials and brings the DTMF tones as they come in. So you can do touch tone owning if you feel like it. You can basically send PCM audio pretty easily. You have to convert it to the raw format, so I need to write some tools for doing sending, but it's pretty straightforward. And you can use all the Warvox 2 code to basically manipulate all the data you pull back in from the Metasploit modules you write. So there's a voice recorder module built in Metasploit that'll basically dial a range of numbers, record all the audio for it, and just give you the raw audio files you can play with the Warvox signature tools. But you can also just do automatically send social engineering phone calls out to everybody. So dial everyone and say, hey, we've reset your benefits password. If you want your 401k, please log into this website. And then you start running your website with set or whatnot, and then you own it that way. So lots of ways you can combine phishing attacks and email attacks and client sides and things like that all together to really destroy whatever your target is. So random legal disclaimers before I go into demos. Two-party call recording states. These are states that require both parties on the call to consent to recording before they allow you to record the phone call. California, Connecticut, Florida, Illinois, Maryland, Mass, Montana, Nevada, New Hampshire, Pennsylvania, Washington. So if you're in one of those states, sorry. It's technically illegal to record someone else's phone call, even if you give your consent to it. Watch out for international recording laws. A bunch of countries have laws against it as well. I think like Germany, Norway, a couple of the ones offhand. And there's lots of state and local laws too that restrict what you can dial, how you can dial it, what considers harassment, things like that. I found out kind of the hard way that certain particular stock exchange forwards all the numbers after hours to one security guard. And I dialed all 10,000 numbers in the range, and he got all of them. And he had a nice peppy British accent that got less peppy as the night wore on. By 5 a.m. It started off like, hello, you've reached the blah, blah, blah. And finally it was like, hello, click, 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 click. Anyways, so make sure you do a little more research on your target range before you annoy someone like that. You might ruin someone's life, or at least night. There's tnid.us you can use for caller ID lookup now, which has basically a full reverse mapping of the US caller database. Asked them for pricing on it, but they haven't responded back. I'll try to figure out some way to liberate it. You can do a cool Google query, which is area code and then prefix, and then 4 numbers, ... 4 new other numbers, all in quotes, and it'll basically return a listing of everything in that range, of that phone number range. So it's a neat little Google trick. Most folks don't realize it will actually tell you matching phone number ranges. And the slides will be online later if you want notes. So Warvox 2.1 is kind of the next step. The idea here is actually extend the UI to manage signatures. Right now it's all command line based and it works, but it's not easy to use. Create a gallery of audio samples of real systems I've found and actually let people contribute, so kind of like an audio wiki, if you will. I'm looking at using SoundCloud for it, but if anyone else has ideas for better ways to share and show off lots of audio snippets, let me know, and be able to annotate it and search the call database. So that should make things much easier, because one thing you run into is like, hey, I found a really cool system, I want to write a note about it. So I've been using like Notepad and VM and things like that to track it so far. It'd be nice to actually do it within Workbox directly. And demo time. So I think that's it. I'm getting close to my my end time here. So we've got 5 minutes, looks like. While I'm running through the demo, any questions offhand? Josh, go ahead. Question, did I see something else, something dialing a car and playing custom recording to half the car? I haven't seen it now. There's SMS-based one that maybe what you're thinking of. Okay. Sure. Yeah, you could absolutely. Anytime that you've got an attack where all it requires is dialing something, waiting for them to pick up and playing a particular noise, whether it's like one thing that didn't make this talk is I had a DOS for fax machines where it just basically screamed at the fax machine until it blew up. And I blew mine up and then it never recovered. So I couldn't repro it because I don't know whether it just fell over because it was old or what, but I had this crappy old fax sitting around that no longer accepts phone calls anymore. I don't know why. And I rebooted it and replaced it, but theoretically you can kill fax machines with this thing pretty easily. I just have to repro it in more machines. And you go to like Goodwill and buy like 10 of them and just go to town. Here's an example of searching for modems. Basically, sorry, this is an example of the Workbox interface. You get a big listing of calls. It does some basic classifications. It'll tell you like dial tone versus fax, voicemail, modem, and so on. Voicemail is based on the 100 hertz beep, like that deet at the end of the call. That's actually 100 hertz usually for most standard calls. So you can automatically identify voicemails by looking for ones with the beep. These days, the beep is getting less standard, so you're actually seeing a wider spread, and the voicemail signature doesn't catch much. This is the one that I like, which is actually a dial tone signature. So it looks for a combination of 350 hertz plus 440 hertz in a particular sample that overlap. And these are all Kentucky numbers, by the way, and very fresh. So here's an example of what happens when you call 1-502-589-6847. And yes, it makes phone calls. So other examples of this.
Reach the law firm of Wyatt, Tarrant, and Combs.
So if you wait till, so you look at this long audio sample here. If you wait to the very, very end of it, there's actually a dial tone way back at the end of it that just starts here at the end. So if you hang on the call long enough, you actually get a dial tone just for free. It's awesome. So it's like, hey guys, if you just call me and hang up for 45 seconds, you get a free dial tone, and then you can dial anything you want, internal, external, whatever. So it's crazy. So other example of this, let's see. Let's pull up just voicemail boxes to show how that works. Well, that's running. I've got a listing of, I think this is just everything. So you can kind of see a big listing of all the calls here. I've got the view matches button, so you can pull it up. A lot of these are actually real people.
Hi, this is Beth. I can't take your call right now.
I have 3 similar businesses.
Thank you for calling Aon, our regular business.
So you get lots and lots of that stuff. So you spend a whole lot of time just basically listening to phone calls, going through it, matching against stuff. There's all kinds of crazy stuff in the sample set. I didn't get a chance to do too much analysis yet. Here's a list of voicemails, and you'll notice that every one of these things, you can kind of see that little fat bar back in the back right of it. That's your 100 hertz tone for the voicemail system that shows up. So it goes deet, and then waits a while, and then does another deet when the message is done. So voicemail's easy here.
Please leave your message after the tone.
So there's your 100 hertz beep, and that please leave your message after the tone bit. You could record that, make a signature out of that, then mass scan the entire back end looking for it. So let's do that. So we're going to click on View Matches, and my code's going to blow up like it does in every demo. And let's see. I think I just broke that code, too. Let me fix it real quick. Actually, you know what? Maybe ahead of time. If anyone wants to see it, I can demo it. I basically added a limit to it real quick. But yeah, actually, you know what? Screw it. I can do that fast. Wrong one. Where is it? Thought I had it. Never mind. Thought I had the editor still up. Oh, that's what it is. Sorry. I was trying to basically limit to the top 50 matches because it was a little bit slow otherwise. But that's okay. We can skip that. And that should fix it. Nope, I failed. Okay, well, I can't fix my demo right now. But you can basically see there's all kinds of fun stuff in the set. Right now, the classification is only based on these 5 different categories, but there's all kinds of crazy stuff out there, and most of it's just being able to dial around enough to find it. See what else we got here.
Thank you for calling Marketing Endeavors. If you know your party...
This is someone being really creeped out. They've got a very long, empty, just background noise one. One thing you find with these a lot is you dial into server rooms that automatically pick up. So you'll call and hear like a lot of white noise in the background. When you find those, just keep listening. Record it for hours, because you'll find like some random guy, you'll hear like a door opens and go, hey, blah, 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 people mumbling around, talking about password. Hey, what's the login to this server? It's great. So whenever you find white noise, those are usually intercom systems or auto pickups in various systems, and basically just sit there on the line as long as you can, record it, and then basically scan the audio later on to figure out what you got. It looks like my time is up, so thank you again, and enjoy the conference.